We're going to take a look at sector area, which is a lot like the length of an arc. Still has the proportional idea that the arc length had, but rather than doing the how much of the circle is it, and then doing that fraction times circumference, do that fraction times area, because you're finding the area. So to get the formula for a sector, the area of a sector is just a portion of a circle, like a slice of a pizza. We're trying to figure out how much area that slice of pizza has, or that sector of the circle. So you do very similar to arc length. You look at the measure, if you know the angle, the measure of the angle out of 360, that tells you what portion of the circle it is. Or if you can tell that it's a quarter of a circle, it's just a quarter of a circle. Times the area formula, pi r squared. So it's just the fraction of area, fraction times area. Just like arc length was fraction times circumference. So we actually have degree measurements here. We are finding the area of the sector, the shaded sector. So it is 210 degrees of the whole circle. So it's 210 360ths of the circle. Degrees make determining the fractions pretty easy. And then you do times area, so times pi times radius squared. So when you multiply, just multiply the tops straight across 210 times 3.14 times 9. So when you multiply 210 times 3.14 times 9, you get 5934.6. Then we still have the 360 in the denominator, so then we finish by dividing by 360. And you get 16.485. To the nearest hundredth, that would round to 49. It's area, so it's inches squared. Same thing for this one. How much of the circle? It's 131 degrees out of 360 total. Times pi times radius squared. So you multiply 144 times 3.14 times 131. And divide by 360. Rounded to the nearest hundredth would be 0.54. 164.54. The units were meters, and its area, so square. Same process here, except might be easier just to realize that this is half a circle. Rather than doing 180 over 360, we could just say it's half. The diameter we're told is 1.6, so it's half pi r squared. Pi, the radius is then going to be 0.8 squared. So 0.8 squared is 0.64 times 3.14, and then divided by 2 for half. You get 1.0048 rounded to the nearest hundredth. It would just be 1.0. Centimeters squared because area is squared. Number 5, we've got the angle is 22.5. So it's 22.5 out of 360 times pi times the radius squared. So you multiply that all out, you get 40694.4 over 360. .04 units are millimeters, and it's squared because area is squared. So you can also apply these to some real life problems. If you want to look at how much area a lighthouse makes visible, you could apply this problem. So the beam from a lighthouse is visible for a distance of 3 miles. To the nearest square mile, what's the area covered by the beam as it sweeps in an arc of 150 degrees? So we have 150 degree out of 360. That's the portion of the circle. Times pi times radius squared. And the radius is going to be 3 miles. So multiply across, divide by 360. You get 11.775 miles to the nearest square mile. So that's going to be 12 square miles. You can also apply it to sprinklers. Circular plot with 180-foot diameter is watered by a spray irrigation system, sprinklers. To the nearest square foot, what's the area that is watered as the sprinkler rotates through an angle of 50 degrees? So it rotates 50 out of 360 times pi times radius squared. We're told the diameter is 180, so the radius is 90, half the diameter. So you multiply that all out, 90 squared first. And then divide by 360. You get 3532.5. And it says to the nearest square foot, so you'd round that up to 33 square feet. And then this last question just says, what if instead it rotated through a semicircle, so 180 degrees, half of a circle, instead of just 50 degrees? So it'd be the exact same question, except you use 1/2 times 3.14 times 90 squared. You get 12,717 square feet.